In the last presentation, we saw the introduction to the Boolean algebra. I explained you this example, and also we did 3 rules in the Boolean algebra. The first one was the complement rule. Then we saw 4 rules in the AND operation. A and A is equal to A and 0 is equal to 0, A and 1 is equal to A and A complement is equal to 0. In the same way, we did for the OR operation. A or A is equal to A or 0 is equal to A or 1, a very important one, is equal to 1, and A or A complement is equal to 1. So this was the rules that we completed in the last presentation. Now we will move to the fourth rule. Distributive law. This is one of the most important laws in the Boolean algebra, and we will solve a lot of problem depending upon this rule. And according to me, none of the Boolean algebra problem asked in the exam will not have this rule involved. You have to use this rule to solve the problem. So this one is very important, and we will see 2 rules in this. The first one is A and B or C. This is equal to A and B or A and C. This is known to everyone, no need to explain. And the second one is little bit weird one, A or B and C. Now this one is equal to A or B and A or C. This is very important, and it is nothing different from this, because here I was having AND operator, and at this point I have OR operator. Here I was having OR operator, but here I am having AND operator. So the operator is interchanged. So I will interchange the operator in the result also. The AND is changed to the OR. The OR is changed to the AND. In the same way, the AND is changed to the OR. So in this way you can remember it. It is very simple. And we use this distributive law when we have A or A complement B. Most of the students will see as the minimized form, because they cannot take OR operation, they cannot take AND operation. So what will they do? They will conclude that this one is the minimum form and this is our answer. But definitely it is not the case. You can further break it into this form, A or A complement. From here you can see we have A, and B is replaced by A complement and C is replaced by B. So I'm just using this distributive law, A or B. In the same way I have A or A complement and A or B. A or B. And you very well know from the OR operation, A or A complement is equal to 1. So we have A or A complement as 1 and A or B. And 1 and A or B, 1 and A or B, from here you can see 1 and A is equal to A. So if I say this A or B is X, let's say this A or B is X. So I have 1 and X. So this is equal to X, and X is A or B. So I have A or B. So directly when I have A or A complement B, I will just eliminate this A complement and I will have A or B. This is the most important part of the Boolean algebra. Very important, and we will use this a lot along with the rules that I have already explained. So this one is important. There is one more form of this particular type. If I have A complement or A and B, then I will eliminate this A and simply I will have A complement or a B. So these 2 things you have to keep in your mind while solving the Boolean algebra, and I hope you will do. Now we will move to the 5th rule, that is our commutative law. The commutative law, Boolean algebra does follows the commutative law. If I have A or B, then it can be written as B or A. There is no difference in these 2 things. And the same way, if I have A and B, then it is equal to B and A. This is a simple commutative law. And the sixth one is associative law. Associative law. And in this, if I have A and B and C, then it is definitely equal to A, B, C. What we did, we took the AND operation of A and B first, then with C, but in this case we took B and C first, then with A, and there is no difference in both the things. Whatever be the output in this case is same as this one. So this is associative and commutative law. I told you the distributive law, and there is one more important thing, which is the priority. The priority. This is no law, but the priority I'm going to tell you. The priority of the NOT is the greatest. Then we have AND, then we have AND, and then we have OR. So first we have to solve the NOT operation, the complement one. Then we have to solve the AND, then we have to solve the OR. This is an important rule to remember when you solve the Boolean algebra. And the last rule, the seventh one, is the De Morgan's law. The De Morgan's law. It's very simple. If you have A or B and then you want to take its complement, it's just a complement law, then it is equal to A complement and B complement. We just complemented the variables, then we have A complement and B complement, and we changed the operator to AND. We were having OR and we changed it to AND. In the same way, if I have A and B and then I want to take the complement, it is equal to A complement. I took the complement of the variable and I will replace this AND by OR operator, and I will the complement of the variable. So this is the De Morgan's law. It is just a simple way to take the complement, and we have completed all the rules for the Boolean algebra. Now we will see one example. The example that I took initially, the umbrella one, in which I had to take the umbrella, and I told you that this Y is same as A or B and C complement, and I'm going to reduce this one to this by using the Boolean algebra. So let's do it. Y is equal to B A C complement, or B complement A C complement, or B C complement. And the first thing that we have to do is to solve the complement. I have already explained you about the priority, and in the priority we have to first solve the NOT, that is the complement, then AND, then OR, and we will solve the complement by using the De Morgan's law. So let's try to solve the complement here. But you can see there is nothing to solve in the complement. We don't have anything like A or C complement. We have simply the complement of the variable, and you cannot solve it further. Then we will try to solve for the AND operation. We will see if we have A and A and 0, A and 1, A and A complement. We will try to have this combination here, but unfortunately we don't have. Then finally we will move for the OR, and I can see this AC complement. This AC complement is common in the first two literals, so I will take common AC complement, and in bracket I will have B or B complement, and this one is written as it is, BC complement. So what if I have B or B complement? What is the result? B or B complement, what is the result? Let me show you the result from here. A or A complement is equal to 1. So if I have B or B complement, definitely it will be equal to 1. So Y is equal to AC complement and 1. This B or B complement is 1, or BC complement. If anything is ended with 1, like X is ended with 1, the result is X. From here you can see A is ended with 1, we have 1. So if I say this AC complement is X, I'm solving it here, then Y is X and 1, or BC complement. X and 1 is equal to X, or BC complement. X is AC complement, so I will write AC complement or BC complement. This is Y. Now these two things are definitely equal. If you want to use the distributive law here, then it is equal to AC complement. I am just using the distributive law, or BC complement. So AC complement or BC complement is the same as what we have got here. So in this way you have to solve for the Boolean algebra. You have to use the rules that I have explained you. It is better if you write these rules at some point and try to solve few more problems. In the next presentation I will explain 2 or 3 problems, and that will help you to solve the Boolean algebra. And you can see we have reduced the number of gates. Here we were having more gates as compared to this one. So this is all for this presentation. See you in the next one.